the algorithms and software. And I'm happy to welcome everyone who has joined us here, despite all the difficulties, and everyone who has joined us online. Вы первый, да? Да. Yes, and the first speaker this morning is Vladimir Anatolievich Alexander Hurwitz is going to be the first speaker today, and he's going to speak about digital economy, digitalization, and software engineering. Yes, thank you very much. Welcome.
Добрый день.
Hello. I do not have slides today because my presentation has a discussion nature. And the name of my presentation is as follows: Trade and Commercial Financial Web, Economic Space Free from Domineering IT Giants. What is economic domineering? Economic domineering is strife that has existed for centuries, and there is nothing new in today's era apart from the things through which this economic domineering can be affected. For example, 2 generations ago, the Japanese developed the following phrase. They said that technological leadership will depend on the people that will be able to introduce as many elementary elements as possible into a matchbox. And a generation later, a meme appeared. Leadership depends on the volume of the information possessed and speed of access to it. And what can we see now? The current largest corporations and leading countries, first of all Western countries, are trying to maintain domineering and technological leadership on the basis of rules. What are rules? These are the standards that they determined and patents they own. It's no secret that the discussion between the USA and China is based on the USA saying, you stole our technologies, and the Chinese say, you decided to possess these patents forever, and you do not let other people use it and develop. Today's economy, today's economic space is formed through service cores, and these service cores are formed around largest transnational corporations and financial and banking system. These are the ones that want to become the main beneficiaries of the life that is based on the rules of a new form of digital domineering. Quite frequently, we use such words that Russia needs digital sovereignty. And what is it? As I understand, digital sovereignty is an opportunity to take part in the formation of values and receipt of income from participation in the formation of these values. This is not a North Korean variant of self-isolation. This is the right to participate in the development of standards and basic solutions of digital world. What is a digital space? Now, I'd like to quote several calls given by President Putin. He decided to introduce them in 2015. As early as 2015, at the Economic Forum in Vladivostok, Putin said that it was necessary to establish a unified economic space of digital economy in Asian Pacific countries. 1 year later, in his message to the Federal Assembly, the President said that it was necessary to establish digital space of digital economy. In 2017, the Bank of Russia received an order together with the Russian government to develop regulatory sandbox as polygons for developing innovative financial technologies to prepare a unified payment space of Eurasian Economic Union countries. In 2017, the program of digital economy was approved. Within this program, the programs of digital transformation of state management were developed. And this year, in November, the President signed a decree on approving the basis. Well, I'm sorry for reading it, I cannot memorize all these names. So, the approval of the basics of state policy in the sphere of strategic planning in Russia. And this document provides for the establishment of a unified information state for the benefit of strategic management of the country. In particular, it mentions the unified digital information analytical platform of strategic management of the Russian Federation that is aimed at collecting analysis of data, assessment of the dynamics of strategic national priority implementation and strategic planning documents for the information support of the participants of strategic planning when taking managerial decisions. And actually, to understand all of that, not from the standpoint of wordings, but from the standpoint of its meaning, I think that it will be quite good to look at the triad, including meanings, infrastructure, and technology. So, meanings, this is answers to the question why. Infrastructure, this is the answer to the question on what basis. And technology is the answer to the question how. And indeed, to establish a unified digital and information space, actually its aim is to improve the efficiency of the economy management, to improve the life of people, and this is the principle of any social state. And recently I learned that not all states are social states. For example, the Constitution of the USA does not have this notion of social state. The USA actually committed to provide for the best conditions for business. And the idea of social state is actually included into social states like Russian state. But in parallel to the efficiency of economy management to improve the life of people, it's necessary to resolve the tasks of the country's sovereignty that should be achieved by changing the role of the Russian Federation in the digital world. The Russian Federation, for quite a long time, actually followed the motto of qualified consumer of contemporary digital services. And speaking about the standards of systemic software that actually determine how to use various standards and infrastructure, it is necessary to develop the competences to develop our own stack of managerial needs. These are needs of production for programmers. And what can we see now? Not only now, actually. So what are the new developments regarding technologies? First of all, new technologies are stimulated by dramatic growth of information spaces subjects. For example, quite recently, the users of information systems were millions. When mobile phones appeared, the number of users can be measured by billions. The number of mobile phones is about 80% of the Earth population. It means that more than 6 billion people have mobile phones. And when the Internet of Things appeared, the number of subjects of information spaces will grow by 10 to the power of 3 or to the power of 4. It means that the number of subjects of information space will be trillions, dozens of trillions, and all of that are subjects of information interaction. These are subjects. And we can see growth of the number of the offered services. This growth is quite dramatic. The experts from ITC think that with the development of the Internet of Things by 2025, an average person on Earth will interact with connected devices about 4,800 times a day, and about 20% of the generated data will be the information received in real-time mode. More than 95% will be the data received from IoT devices. And actually, it means that the existing management systems require principal change, new solutions. Well, I do not want to repeat it. First of all, it is associated with the dramatic growth of the number of digital information, communication, interaction subjects, the requirements to change management systems, not the applications, but management systems. I would like to repeat it. This is a window of opportunities. This is an opportunity to propose and develop production of systemic software and instrumental means. This is production of the means of production for programmers, and in its turn, it will determine our participation in the development and promotion of new standards of open software. Deloitte says that contemporary digital economy is the activity that is the result of balanced daily online connections between people, businesses, devices, data, and processes. And today, we are dealing with the economy of connections. World Wide Web, web pages is the stage. So the web of pages, will actually be substituted by the stage of digital twins that cannot be understood as cyber physical models. I apologize. This is a good illustration to the subject of your presentation. Well, we are always connected. That is true. So, in the industrial internet, a digital object or a digital model is a cyber physical model. And we suppose that in the new digital internet, trade, industry and finance internet, an object is a semantic and ontological model. A simple example. An object or a digital twin can be a car, that is an engineering structure, and can be a bill to buy or to sell a car. This is also an object of digital space. And a consumer perceives the semantic and ontological model of an object within the requirements and features that they expect to receive from this object. The person who buys the car will be interested not only in cyber physical model of the car, but also by the bill. This is semantic and ontological model. And I would also like to emphasize another issue. Today's digital and service economy is directly related to the issue of data control. Actually, today, almost everything is offered as a service. So Huawei formulates it in the following manner: to provide for ubiquitous accessibility of infrastructure as a service, for flexible innovations technology as a service, to develop most advanced practices, expertise as a service. And in exchange to the provided services, the users should provide their data in exchange for the services. And it actually makes digital giants domineering. They are holders of people's data. And actually, we've seen several attempts to fight this phenomenon. For example, the founder of World Wide Web, Tim Berners-Lee, several years ago, organized Solid project. This project provides for providing every user control over their data. This project attracted more than 800 companies, thanks to the authority of Berners-Lee. But as you can see, in the information space, we do not see a lot of information about this project, although it has existed for several years. There is an abrupt management company, and it is quite clear that this project is an enemy of domineering digital giants, and it's not surprising that it's absent in the media space. Trade, industrial, financial internet, or the internet of objects and digital models will provide control over the data of an object to the developer of this object, and this is complete control over a person's data. As I already mentioned, the most important task of today's world is commutation of multi-object world and management of proactive objects that is implemented through complete technological stack to provide for efficient and safe work of service cores of a new economy. This is the way we can define this task. And what can this stack include? It includes the server of transactions, supervisor of objects, and a media server. The server of transactions. This is a management system aimed at launch and dispatch heterogeneous cloud applications, providing for the necessary level of reliability and safety, interacting with various types of terminal devices, high-load and scaled-up systems of mass service. And we can refer to this transaction service using a specific term. My colleague will speak about it later, and it implements a unified throughput technology for developing applications, change of integration management connected with the scalability for high-loaded systems. This is one of the key elements whose concept has been developed. Together with supervisors of objects, distributed management systems and media servers need to store a lot of data, and we can receive a completely independent stack with an open source code. And in conclusion of my presentation, I would like to point out another aspect. The development of systemic software is closely connected with the establishment of the culture for consuming, creating, and preserving competences, and that is especially important to mention here in the university. And this task was resolved in various countries, so the engaged students, postgraduates, and researchers working in universities and laboratories to resolve this task. And now we need to understand that there is a window of opportunity to participate in resolving the tasks that can change the world and the roles of the countries, huge groups of people in this world. And when the leaders domineering today try to make huge masses of people a herd of consumers that will continue to eat what they receive, and these giants actually will decide what they offer to the society. But now we do have this window of opportunity to avoid this situation, not to be an obedient herd, but rather try to resolve most important tasks that will make a difference, that will make wider masses of people the beneficiaries of decisions that now do not participate in this process. That's it from me. Thank you.
Colleagues, good afternoon. I'll try to make my presentation concise, and my report is dedicated to one of the technologies named Greener Transaction Services, composed by the Commerce of Trade, and it will digitize the follow-up technological lifestyle. Why do we need this particular approach and such technologies? If we reiterate what happened back in 2008, it featured quite a number of smartphones emergence and application of new technological solutions, and thus new approaches were necessitated, plus some new technologies. More efficient internet services in Jinx, for example. And today, the role of integration of platforms and big-size nucleus is growing, and some sophisticated architectural solutions are provided, and some of them look like Frankenstein, and at the same time we once again reinvent a wheel. And we also have quite a number of elements to have some similarities. Some bypasses are necessitated to bridge the gap between various technologies, so security, safety, authenticity, and other factors are predominating now. 3W originator Tim Berners-Lee actually was concerned about it. And we're talking about the mass-scale technical debt for servicing the population on a mass-scale basis. And it's real hard to resort to the old solutions, so we have to rethink them and rebuild them. And everybody transferred to PC, and the efficiency of this PC started growing. And code was not put onto the forefront, but the speed was predominating. And applied tasks were in greater demand. But as the number of users were growing, and there are billions and billions of them, and the services are now being integrated, so engineering efficiency nowadays is put onto the forefront. And if we have a high efficiency of code by 10%, it may cost, as a part of a hardware, dozens and dozens, millions dollars. And so we would like to get back to the higher efficiency of computer engineering. And in order to have these systems work more effectively, we need some basic abstractions. And if we have some primitive abstractions from the perspective of the structure, that's the one thing, but this primitive approach and abstract approach are now prevailing. And it's worth to mention that these approaches for compiling abstractions were the focal point of the Russian-based developers. And the architecture allows them to use quite a number of new applications, and computer science is a part of our history in that particular sphere. And why are we talking about the new technological base establishment, which should be the best in the world and having large-scale potential? Back in '59, the party leader received a report on the creation of the unified system of PC in the emergency period. And Antonov Vasil Ivanovich was the founder of these technologies, and he promoted the idea of Internet. And fundamental principles are still in place, which he formulated. Quite a number of scientists supported this report, but military and defense sector did not want to extrapolate these efforts onto the business and economy of the USSR. Mr. Glushkov was another originator of these ideas, and he promoted our industry, and the programmers of the unit headed by Mr. Sinkov. So we decided to once again relying on some new solutions of their lab, and it is now ahead of other solutions. Telemeter Office was applied to a number of entities, and it was some kind of an interdisciplinary data exchange for Gosplan, for MOS Transprom, and quite a number of automated systems were required, and the new software had to be designed. That should be the state-of-the-art system. But back in the USSR, these findings were not in a great demand. But telemetry OP developments were reinstituted further on in 1996, and a new technological concept of Internet was implemented, at the first interactive Internet saw the light. It was Baikonur findings. I have to somehow speed up, and it's worthy to mention that we saw a chance to compile new software architecture made of standalone bricks. And Epson Technologies and Intel put together more than 130 organizations, including State Duma, RAO Gazprom, and the Office of the President, and other organizations of that sort. And the Central Bank and the State Duma used the Baikonur technologies for their serious solutions as a baseline one. And back in 98, Intel had to measure the efficiency. And if we have 10,000 users and 6,000 applications, so they managed to survive on a real-time basis. It was 133 megahertz. And within the framework of the financial internet and economic exchange, the project for technological base had to be provided, and that is GTS, server of transactions, supervisor of objects, and media servers, and also some instrumentation provided for the fast applications generation. And the technological basis was prepared for that, and GTS had to launch heterogeneous cloud applications, and it is necessary for the safety and security of terminals, and if they have mass scale loadings. And we may use this system for SMEs and scale it up for the corporate and public projects. EBP projects automatically becomes the one to serve the needs of millions and millions of users without recoding the software. And these transactions will be worth 5,000 transactions a second, and it could be 0.5 million of plugins. And the server will be accessible. And this technology will allow us to have more applied systems, and their efficiency will become by 10 times higher. This is a key parameter, minimizing the cost of ownership. And I'm going to This will allow to have a new architecture, scaling up the security and safety. And as the architecture is quite a comprehensive one, and some other applied solutions will be provided by the designers, and we will have the universal digital space for the economy and business. So we are supposed to have uniform standards, which is indispensable, and the trade industrial internet will form the technological culture which allow us to have the baseline solutions in place. What do we mean by the process culture? I mean the team of designers who will safeguard the guarantee of their working ability for dozens of years and actually have the basis and good reliable foundation for all the operations and transactions. Plekhanov University is supposed to be the key platform for training specialists of that sort and be a part of this large-scale project. Thank you so much for your kind attention. Thank you. Thank you once again. Wonderful presentation with the perspective look onto the future. Dear colleagues, we are somewhat pressed for time, but there are quite a number of other presentations to go, and we would like to put as many questions as it is possible. And it is not only related to technologies, internets, but some devices. And we are talking about the actual reality. And Marina Belyeva, the professor of informatics chair of university named after Plekhanov, and she is going to develop on the digital technologies in the agriculture. Good afternoon, dear colleagues, and today I wanted to make a very brief presentation, and it will be dedicated to the digitalization and engineering and innovations. And as a professor of the Russian Economic University, I'm fully in charge of the R&D sector in the field of engineering, modernization, and the creation of the new tech process equipment. Next slide, please. It doesn't work. So the incorporation of new technologies will allow us to have a high efficiency of all the processes. And first and foremost, they are targeted onto the higher energy efficiency and energy savings. And as of today, as it is well known, I should say that in the field of farming and agriculture, and particularly in the meat processing industry and storaging of grain, we've been dealing with that particular problem. And we actually work in the field of meat processing industry jointly with our graduates, especially thermal processes. And we are in charge of the development of the new process equipment, incorporating the new automation systems with the pertinent software. And over the past few years, especially 3 years, we've been dealing with the following business areas, and even we were granted patents for our findings in that sphere. Will you please help me with the screen? Yes, it does work. Next slide, please. And I would like to emphasize the following, that in order to attain this goal, while transforming the food industry and using digital approaches. So we give a whole list as to how substantiate this project. We have to analyze the methods. We have to digitize the area, analyze specific features of the digital transformation in the dairy and meat industry. I've already mentioned that we are keen on the technical engineering, and also we're focused on the development of innovative equipment in that sphere. What are those state-of-the-art digital technologies applied to agricultural industry? These are sensors, and at various stages of those processes, they may apply from beginning to end, and as a monitoring feature. So sensors provide the health care and health control, and actually they control robotics and process status. Also, they keep track of the assembly lines, performance in the dairy and meat industry, and they provide the quality assurance factor. And also in the food industry, we have 3D printing, and it opens up some new opportunities for this industry. We have pizzas, we have cakes, we have tarts, and we apply 3D printing. Then blockchain and is another option, and transparency has to be provided, and blockchain technology will retain the confidence of a consumer. Also, AI becomes the part of this process for meat and dairy industry, and it is interconnected with the problem of quality, and quality control is relying on the machine eyesight, and we also have the real image of the world plus virtual information. And next stage is augmented reality. What are these innovative processes to mention? First and foremost, this will be DNA chips, scanners, so machine eyesight, and also innovative products development, innovative equipment application, plus food supplements and products from new ingredients extracted. Also, we have robotics in the pipeline, modification, automation, and mechanical approach for processing, and innovations in the recipes, and using non-traditional feedstock. And at the very start of my presentation, I've mentioned that we are targeted on the resource-saving and energy-saving methods and ERP systems incorporation. And nowadays, technical engineering is in the pipeline, and we have to prepare all the production processes and thus implementing them on a full-scale basis, and also up to the stage of the product distribution. Within the framework of the Russian Economic University, we are able to be a part of the R&D processes, especially related to the optimization and improvement of these processes in the meat and dairy industries. And we have to be guided by specific criteria as to retaining a high level of quality of products. And we also, jointly with our postgraduates, developed a new methodology that is an innovative device for thermal approaches to the grain mass. And when we store the grain, it is subject to some microbiological processes of fungi emergence. And so we use special sensors keeping track of this milieu. And when we put the sensors onto the grain mass, it is somehow being air conditioned and thus retaining grain intact, and also the patent was granted for that particular findings, and that was the developments, R&D developments under my guidance. And so we also have some new equipment for thermal processing of meat products. It's also protected by patents, and we may be infinitely discussing digital transformations and technologies. And today I wanted to share with you some specific takeaways of our work. We already have infrared drying facility, and it's all fully automated, also protected by patents. And they have the system of temperature control, retaining the temperature at a specific level, and we use LabVIEW system. And finishing up, let me emphasize that we have a vending automated system with the furnace embedded, and that what happened over the past 3 years, and we've attained the real very good results in here. And this is a list of patents obtained in 2021. Thank you for your kind attention.
So, am I right that today you can monitor agriculture animals, cattle, from the space? Yes, that's true. Actually, the problem is as follows. To provide a quality product to consumer, we need to monitor this process from the stage of growing animals till processing. And depending on the recipe, what we offer to the consumer, well, of course, it is all aimed at improving the quality of food. Thanks a lot. And today there are algorithms similar to immunity, and Piotr Karpov will speak about it briefly. He is a researcher of the Laboratory of Business Analytics from Plekhanov University. Piotr, you have 3 minutes only. Please try to be brief. So we request you to switch on the slides. So in my presentation, I will briefly speak about our biosimilar algorithms, immunosimilar algorithms used to resolve these tasks. Next slide, please. Natural immune system is a very complicated mechanism. It is based on a cascade of very complicated biochemical processes. On this slide, you can see a scheme for activating B cells. At first, antigen is fragmented. Peptides are presented to T helper cells. T helper cells are activated. After that, they generate lymphokines that result in activation and propagation of B cells that generate antigens that, in their turn, neutralize pathogens. And the idea of immune-similar algorithms is to use such principles of work borrowed from the immune system to resolve specific tasks of machine learning. There are various classes of immune-similar algorithms depending on the principles that are used. Algorithms of negative selection use the principle of dividing friend or foe. Algorithms of clonal anti-selection are based on the principles for reproducing B cells to get immune response. Immune networks are used to resolve clusterization tasks, and there are other immune-similar algorithms that are based on different principles of immune system. For example, the algorithm of dendritic cells, the algorithm based on danger theory, and others. So, how does this algorithm function? There is a specific analogy between the work of immune system and the tasks of classifying. When antigen corresponds to a specific data sample, antibody is a structure of data, and the result of classification is immune response. And on this slide, you can see the task of classifying. The circles represent artificial antibodies. Colored dots are data samples with various classes. And, depending on the distance, artificial antibodies can bind with data samples that are closer than specific binding threshold. I would like to tell you about Wallace's algorithm. This is our development. The classification is based on voting. When artificial antibodies bind with data sample and every antibody votes for its class, and by the majority of votes, we can determine the class of the data sample. So the algorithm of training, I do not want to dwell upon it, is based on genetic algorithm with niching to develop huge population of diverse antibodies. And on this slide, you can see an example of teaching on a test data sample with 3 classes. The first generation is the system that was just initiated, and the picture on the right is the system that had already been trained. 600 generations. You can see artificial antibodies covering the whole set of data, and this is an example of training on a popular Fisher data set. You can see the dynamics of teaching. And so the specificity of classification, the accuracy of classification. On the radio diagram, you can see the accuracy of classification of Wallace immune-similar algorithm, and on other diagrams, you can see other popular classification algorithms, and we can see that the accuracy of immune-similar algorithms is very high, and actually it can compete with other popular methods of machine learning. Thanks a lot, Piotr. Well, there is a small, short video, 30 seconds only. That is our development. Yes. Okay, colleagues, let's thank Piotr, because actually we have to give way to another event that will start here very soon. Thanks a lot.
Большое спасибо. Наша сессия закончена.
Thanks a lot. The session is over. The next event will start.